Hello. So we are starting our next unit. Our next unit is dealing with statistical analysis. So this is the very end of our entire probability and statistics lessons all coming together. So it's very exciting. And after this, we're going to move into calculus, which is also very exciting. So the statistical analysis unit is wrapping it all up and kind of talking about like the official way that we do statistical analysis in the real world. So we're going to talk about a lot of like processes that we need to follow, and it's because in order for these statistical analyses to be accepted as truth, we have to follow a certain set of rules, so then that way it's consistent among all statistics. It's kind of like these like rules that all statisticians have to follow. It's really complicated and it can get really confusing. And so I just wanted to take a second and introduce a few, by a second I mean a lesson, and introduce a few vocab words and kind of mindsets that you should have going forward. And the first thing that we're going to talk about is hypothesis testing. All of statistics starts with hypothesis, as some of you are noticing with your IA. A lot of you guys are doing statistics IAs, that your IA, you have a hypothesis, you have some sort of theory that you would like to test. And so we start with this hypothesis. So we have something that's called the null and alternative hypothesis. It's been forever since I've done it this way. The null hypothesis is written as H sub 0 is your null hypothesis. And your null hypothesis is always assumed to be true. It's kind of like your default position. Our goal is to typically provide enough evidence to disprove. So I know that these two statements might seem a little contradictory, that we always assume it to be true, but that our goal is to prove or have enough evidence to prove for it to be not true, or enough evidence to disprove it. And the way that I like to think about it is, and a lot of statisticians like to think about it, is that you think about it as the trial and conviction system that is the criminal justice system. Thank you. Sorry. So we are focusing on it as like this idea of innocent until proven guilty. And so everybody, all criminals, we go into a courtroom and we say everybody here is assumed innocent until proven guilty. And that's kind of the idea of the null hypothesis, is that we go into it assuming that everything is true, but that really our goal is to provide enough evidence to show that it's not true. So that can be a little confusing. I'll have additional help links available to you in your Unit 11 resources page for you to practice this. So the null hypothesis always has a counter argument to it, which is the alternative hypothesis. Alternative hypothesis uses the symbol H sub 1. So this is your alternative hypothesis. Your alternative hypothesis is the how you think the position has changed. So for instance, if your true hypothesis is like, hey, I think that the weather climate has changed over the past 5 years. Your null hypothesis is going to be, hey, the weather has not changed. We're assuming that the weather has not changed, but we're going to provide enough evidence. We're going to try to provide enough evidence to prove that the weather has changed, and specifically the weather has changed to go warmer in the past 5 years. And that would be your alternative. So your null would be the weather has stayed the same, and your alternative would be it's actually gotten warmer in the past 5 years. And so that's the idea of that. Typically the thing that you're trying to prove is the alternative hypothesis. But the only way that we can really truly statistically, mathematically prove it is we can only prove that the null hypothesis is not true, and therefore we can accept the alternative hypothesis. So that's the main idea of null and alternative hypothesis. You have two always, they always go hand in hand because you're trying to use one to prove or disprove the other. So we're going to practice it. That's all we're going to do today is practice these terms. So for each situation, we're going to write down the null and alternative hypothesis for the situations. The mean temperature in Dubai from 1968 to 1998 was 29 degrees. In January 2018, it was 31 degrees. Is there significant evidence that the mean temperature has increased? So this is your similar example to what I talked about before. So as we talked about before, your null hypothesis is that it's stayed the same. And so as we can write that, we can write H sub 0, and then you write a little colon. And then we use mathematical terms to say the average temperature has stayed the same. Average, we use mu, stays or is equal to what it was before. And what it was before was 29 degrees. The alternative hypothesis would be that mu has changed, but not only changed, has increased. So now is greater than 29 degrees. And that would be your alternative hypothesis. And that is all we have to say there. Okay, that's it. Null hypothesis, alternative hypothesis. This is step one with hypothesis testing. We're going to go into things like the chi-square test, the t-test, p-values, all of this stuff. There's all of these tests that we apply to these statistical situations. And the first step is always to state what your null hypothesis is and what your alternative hypothesis is. And then you go in and start doing your calculations. So this is like step one. That's why we're practicing it. Hans collects data on the average house price and the distance from the nearest train station for 8 villages. He calculated the value of the correlation coefficient to be negative 0.631. Does this provide enough significant evidence of negative correlation between the average house price and the distance from the nearest train? So this one is a little bit harder to write mathematically, and we don't always have to write it mathematically. We could just write it as a sentence. So for your null hypothesis, you're trying to show that there is a negative correlation between the average house price and the distance from the train. So you're trying to prove that, like, hey, it pays off. Like, people want to live closer to the train station. So it's a more expensive price the closer you are. So you're trying to disprove that the prices of the houses stay the same, right? You're trying to disprove that the normal, the accepted normal is, you're trying to disprove that the accepted normal is true. So that accepted normal idea, the null hypothesis, is that there is no correlation. Between B/W, between the average house price and the distance from the train station. Now, the alternative hypothesis here is not that there is a correlation. The alternative hypothesis here is that there is a negative correlation. And if we think about that for a second, and then the rest of what we said before. And if we stop and think about that for a second, it might not make sense at first because you would think that the original hypothesis of there being no correlation, that it would not, that the alternative to that would be that just there is a correlation. But since we have found a Pearson correlation coefficient that is negative, the opposite of no correlation here is that it is, and that it's negative, because we found a number that says if there's anything, it would be negative. And so we're trying to show that negative 0.631 is enough of a negative correlation to prove that there is a negative correlation, enough of a negative number for Pearson in order to prove that there's a negative correlation. So that's why it's the alternative hypothesis. And we're going to talk about one-tailed versus two-tailed right now. And this is an example of a one-tailed test. So a one-tailed test, the reason why they're calling it a tail is because we're talking about these guys. And so a one-tailed test is like, okay, we want to know if there's something like maybe our null hypothesis is happening within here, I guess would be, yeah. The null hypothesis is happening over here, and then one tail of it being, okay, well, if it's not the null hypothesis, then it is something that's behaving in a positive way, or maybe it's something that's behaving in a negative way, or maybe it's something that like, to not risk confusion, I'm just going to leave it at that, that the idea of a one-tailed test